afternoon, gentlemen.
Good afternoon.
Yeah, I like people who can actually learn from their experiences. All right, so today, this afternoon, again, I'm going to stay with the same type of theme. I'm letting all the smart guys handle the racks and the PNIDs and controls. All I'm going to do today is play. I know some of you already volunteered, but what we're going to do is I'm going to hopefully teach you a couple extra tricks to get you out of there. Today's class, this afternoon's class, I should have called it How to Get Out of There at 1:30 in the morning. Yes. Because that's my goal. My goal is to get you home without calling the customer and saying, well, hell, it's CO2. I don't know what the hell we're going to do with it. I'm just going to the house. We're going to do some things. Maybe they're ethical-ish. I'm not jumping out any phase loss monitors. I have enough pictures of those to make a coffee table book. We're just going to talk about what happens when the high pressure control valve fails. We're going to do some calls. I'm going to run some service calls. I'm going to tell you some phone calls I got. I'm going to tell you what they said to me. You tell them. You troubleshoot it. Help me troubleshoot it as we go through there. Is everybody cool with what we're headed to do? Yep. All right, so anyone that's going to do something smart or better, now's your last chance. We'll close the door. All right, damn it. All right. Remember, I gave you a chance. All right, here we go. So, I want to start off with a couple of things. I want to make some clarification. You're probably hearing a couple extra different things. They're not that far off. You know, where's critical point? Where's triple point? Some people are giving it to you in absolute. Some are giving it to you in gauge. Everything I'm going to do is in gauge and Fahrenheit. But I do want to talk just a second about advancer. And it doesn't, I should have taken advancer out. Because the things I'm going to tell you will work on my rack, Hillphoenix. Will work on the KW rack, which I was offended was in my slide. The zero zone rack. It's going to work on the Emerson rack-ish. The process and thought process is going to work on all of these racks. So I want to cover that, as I said yesterday or earlier this morning. Don't make this harder than it has to be. Some of y'all are calling me. Does anybody who's been in my class before know what CO2 panic is? All right, I'm in California. I don't know if I'll go to jail. I might have to leave. I'm going to use a term. California. Gavin's not here, is he? Just checking. CO2 stupid. Oh, I didn't see how quiet y'all got. Oh my God, you said that. Does everybody know what I mean by CO2 stupid? Yes or no? You walk into a rack, it's CO2, it's 2 in the morning, you're popping off on the receiver, your suctioning on both racks are high, and you walk in the rack, and immediately everything you know about thermodynamics is just what? Left your body. You walk in and you're like, oh my God, the rack is done and it's CO2 and I don't know what to do. Nobody will answer the phone. What do I do? Stop. Breathe. Not the CO2. Some of you guys got to quit huffing this stuff, man. But breathe. Understand at the end of the day, this is nothing more than a what? It's a rack. It's a vapor compression system. Oh my God, I put CO2 in it. So what? Put vapor pressure at about 100 psi and let it simply change state. It's not that big a deal. You know how I know that? I'm the first person in North America to turn an entire receiver into dry ice. So I know what I'm talking about. It's not horrible. It's embarrassing, but it's not horrible. It's a vapor compression system. CO2 has high volumetric. You're hearing everybody say that. The BTUs per pound are awesome. Basically, that's what we're saying. And everybody's saying it. And if you want to prove it, don't believe anybody here. That's what I say. Go to the liquid line. Go into the store, look at the liquid line. Go to a 12-foot open case. Look at the liquid line, look at the suction line, and look at the risers. They go to a 404 store, 448, whatever you can legally put in California, and look to do the same thing. And make note of the line sizes. That's all I'm asking you. And you'll see what we say when we talk about high volumetric capacities. Pop the heads off the compressors. Look at the cute little pistons. Anybody ever pop the heads off a Bitzer, low temp? Big as a toonie, if you're Canadian. Just trying to represent. But they're so cute because of the capacity of them. That's why I can do that. So I want to hit that real quick. At the end of the day, how many people ever hear me call this a transcritical rack? You will never hear that coming out of my mouth unless it's actually what? Transcritical. Using the term transcritical is like using the word Freon or Kleenex as far as I'm concerned. I'm sure a lot of guys all the smart guys are gonna disagree with me, but look, it is a booster. What do I mean by booster? I'm talking about 2 sets of compression using 1 refrigerant. Yes? Two sets of 2 compression, medium low, 1 refrigerant passing between the 2. Discharging the low temp compressor into the medium temp. Anybody ever work on a Carlisle 2-stage back in the day? R22 low temp. Is that a booster? I'm taking 1 set of compression, I have an interstage to the other set of compression, I'm compressing here on the interstage, reducing my compression ratio, allowing me to go low temp R22 to ambient without too much heat built into the compressor, amen? Yeah. I'm basically doing the same thing here, it's nothing new. This is not hard, nothing new. So we just want to keep that in mind. I'm dumping the low temp, my low temp discharge is about this big. Going from here to there, done, done. All right, so just keep that in mind. It's a booster. And here's one way I want to point this out too. All right, let's say it's 70 degrees outside. Is that rack transcritical? No. Does that have to be above 87.7? But is it a booster?
Yes.
If it's 95 degrees outside, is it transcritical?
Yes.
Is it a booster?
Yes.
If it's 30 degrees outside, is it transcritical?
No.
Is it a booster?
Yes.
Everybody get my point? It's always a booster. That's the technology. And at certain conditions, and we're going to talk about those conditions. How do I handle that? How do I handle that 1,300 pounds? You notice everybody always goes high, but it's more going to be around 1,100, right? Depends on where you're at. You're in Reno Valley, but if I have BAC, I'm good, right? But it's going to run at a higher pressure, all right? So I just want to make sure we're clear on that before I start. So when we start looking at these systems, this is a basic drawing, yes or no?
Yeah.
And if you walk into any of these racks, you look at the Emerson rack, they Europify it. I'm going to make it look American. That's how I roll. And so this is quite simple. Is this a simple rack? Look at it. It's a very simple rack. But what makes this rack different? Everything else here is yeah. But what makes this a wee bit different is the high pressure control valve and the flash gas bypass valve. I have different options. We're going to look at some of those options, how we do it. We are going to fire up an ICMT because it's a lot of fun. But those are what helps me manage my COP, coefficient of performance, my energy, when I'm supercritical. He's going to manage the pressure inside here. It's very simple. The controller, whatever controller I'm using, and I'll give you some options. I could be using the 326A. Can I get an amen? No? Come on, dudes. This is awesome. So the greatest controller I ever had, designed just for CO2. So what do we do with it? We get rid of it. We can go to the iPro, the Emerson version, and we'll give you some others. But these are the 2 valves I'm controlling. And I don't care what you have. You're going to have a droplet pressure right before the high pressure control valve. Right before the high pressure control valve. You're going to have a sensor. I always say drain leg. And one of my engineering buddies go, well, you know, the drain leg could be, I'm like, all right, 6 inches outside the condenser on the liquid line coming back to the receiver, i.e. the drop leg right out of the condenser or gas cooler. All right, so I'm going to have those. Those are going to be my temperatures, and I got a receiver transducer. I'm not going to talk about specifics. I'm just going to say it doesn't matter who you're using. We have these inputs. I have my outputs. I'm typically, if I'm using a high pressure ICMT valve, I'm going to have a 0 to 10 volt signal that's going to drive him based on COP. We'll talk about that in a minute. If I'm using a CCMT valve, then I have to have a valve driver. So I'm going to be using a valve driver to control that. So we'll talk about both of those. And then on the receiver, I'm also going to use some type of, now most of the ones we have out there, we got 800 of some of these that Hillphoenix does. The majority of them have a CCM valve. And we're gonna equate these to some other valves later, right? And so everything else, I'm gonna let other people talk about. So that's all we're gonna do today. So when I look at these things, I could use iPro. So when I say your favorite controller, give me a heads up. iPro. My opinion as well. Microthermo. Canadians represent. Now, come on, Trevor, represent, baby. So if I'm going to do microthermo, if I'm not using a 326A, which they did in the beginning, now they're going to run off a 742V, which is a stepper valve driver. It's going to control my steppers. I got an analog on my 722F, so that's going to send the signal to my high pressure control valve. If I want to drive both of these valves, I'll do that with 2 stepper valves, because now my high pressure control valve is a stepper, so is my CCM valve. Are we good so far? If you need me to stop or back up, let me know. Oh, again, woo! Andy, I know everything there is. Represent, brother. I can make this thing go get the paper. I love this controller. So, when you have a controller that's designed perfectly, designed in the Danish Institute of Technology when we're doing this, when you have that control, and people love it, what's the best thing to do with it? Fade it out. Put it in sundown mode. So now, they can't get the chip, so now there's a couple options. Paul Burnett and I are having disagreements. I'm a fan of the 722. That's the Danfoss controller used for mini boosters, but it has an analog output, and I put a 208C board, that's a stepper valve driver. I tie that to it. Now I can do the same thing, the 326A, and I'm still doing it per Danfoss original algorithm. All right? And the other suggestion, you can do a 781, but you have to add a 103 and a 208. And the new kid on the block, no, you recognize that real quick. So I have the 300T. Corel now has a rack controller. And it has an output, a 0 to 10 volt signal, typically on J20, that I'm going to sense the 0 to 10 volt signal to the high pressure control valve. But they don't have a valve driver on board. So for the CCM valve, I'm going to have an EVD, which gets another Modbus address, which adds to my network, but I have an EVD driver. How many people know what I'm saying when I say a valve driver on board? I'm talking about being able, having the hardware and the ability to drive a stepper valve, a bipolar 4-wire stepper valve. Are we good? Like an SER, something similar to that. So that's what I'm saying. Some of these controllers have a driver on board. Some, like Corel, I have to have a separate controller. iPro, I can use the iPro for the high pressure control valve. I have to have a Dixel controller to send my 4-wire stepper valve. But they both have to be connected to the network, and they both have to. Nice thing about the iPro is I actually have a nice display right there, which reads in Fahrenheit and pressure. Everybody else is in bar and Celsius. So I guess everybody's decided to make US go SI, so we'll deal with it. All right, so those are different options. but they basically still have the same algorithm and they operate the same as what I'm going to go through right now. All right. Some of you've heard this before from me, so I'm going to repeat it. I apologize. So I like to think of this thing as running in 3 modes of operation. Some people don't identify the different modes. Some people say subcritical, transcritical, and damn, it's cold modes. So I'm going to break it down into 3 modes. This is the way I personally look at it. Are we good? So when I say mode 1, I'm talking about running between about 41 and 85-ish. Mode 2, greater than 85, when it's 104 on the roof. You want to watch people pucker up, go to a darn call at 104 the first time and see it running at 1,200 pounds. Right? And then mode 3, my holdback mode, below 80 or below 40. It's cold out. I'm going to use this as a holdback valve. Are we good? Yes? All right. So let's start here. Let's start at mode 1. There's a set point on these controllers. Some of them are internal. On the 326A, I can actually set it. The 772, I can set it. I think I can set it in Corel, but I have a 3 to 5 degree subcooling. Are we good? So what I'm doing is I'm saying to the controller. Now remember, everything, this line right here, and I'll talk about that in a minute. That is my COP line. I'm going to drive this valve based on coefficient, how efficient I can make that system in transcritical. Is that we good? When I'm not, you say something, stop me. Stop me if I have to. But in mode 1, I'm going to go, look. You walk up to the controller and you're like, dude, what are you doing? Why are you regulating? Where are you moving? He's operating, he's regulating. So obviously he's doing something, yes? He's at 44%, he's at 45%. He went to 38%, oh, he's 46%. He has to be doing something, yes or no? Yes. He's regulating. What's he regulating me to? He's pushing me down the gas cooler. Ooh, I have a board with chalk. I can't believe they gave me this. And I can't read it. So there's my critical point, yes, top of the dome. That's 87.7. So I'm going to say, hey, look, everything out here is what? Subcool. Everything over here is superheat. Oh, sorry. Everything over here is subcritical if it's above that line, yes? Everything inside of here is saturated. That means it's a liquid vapor mixture. We good? So what we're doing is we're saying, okay, if I want 3 to 5, depending on who set it up, I can draw this line. If I draw this line 5 degrees off of the liquid saturation line, then I'm 5 degrees. If I'm right here, I'm 5 degrees what? I'm subcool. So what are you doing, dude? Why are you moving like that? What he's doing is he's regulating you coming out of the gas cooler based on COP and temperature of the sensor coming out. He says, dude, I want to be here to make this the most operative system I can. And then when I come through here, I push through this valve. Yes? What's going to happen when I push through this valve? It's got a small orifice in it. What's it going to do? What's going to happen? Pressure's going to drop. And I'll pass all this stuff around when we get to it. So the pressure's going to drop. Boom. Yes? Create a liquid vapor mixture into my receiver. Yes or no? Makes sense. We learned this on our first year apprentice, correct? Yep. All right, so I'm pushed out and I'm on this line. Let me tell you something. Now, how many people, when you walk out to one of these racks, the very first thing you do, regardless of why you're there, pay attention to the ambient and look and see where he's at. Where he's at. How many people do that? You should be. Because if he fails, I'm going to show you how to take it to manual. Everybody loves the magnet, but everybody keeps stealing my magnet. By the way, I will be searching everybody on their way out. I'm tired of buying those damn things. How do we take this to manual? Go aisle 1, change, enter, I will go through that. But if I want to operate him, just change him to manual. But I have to know where he's supposed to be, yes or no? I have to have the built-in database inside so I know where he should be. Otherwise, I'm shooting in the dark. So what we want to do is watch that. So in mode 1, I'm bringing it down here. I'm trying to maximize my CO2 and I'm creating pressure drop. All right, are we good so far? That's mode 1. Now, when I come in here, let's figure out a way he does this. What I want you to, anybody got a PT chart? Asking refrigeration dudes for a PT chart. Nobody has one.
Right here.
It's on the rack.
All right, pop up.
There you go. It's on the rack. There you go.
Yeah, it is. Go there. If you need one, you're not going to catch me without a PT chart. I got a whole stack of them. Nobody want one? Here.
Take one down, pass it around.
Paul gets very impatient with my low tech. So I'm going to look here. What I want you to do is once you get this, I feel like a dealer in Vegas. Take some of these and pass them down. So, how am I actually managing that? Let me show you what the controller's thinking. I told you where he's supposed to be, but what I want you to say, so you'll see a point where it says pressure and it'll say reference pressure. And it doesn't matter. The algorithm is basically the same. Danfoss came up with it. Everybody else is doing their version of this. So, somebody tell me what the pressure at 70 degrees is. The pressure at 70. What is it?
838.
838.
What do you just eat? All right. So let's say it's a nice 70-degree day. We're running a 738. We good? As we're running through the system, the high pressure control valve is regulating. He's regulating for me. He's at 44%. What is he doing? So I got to create subcooling. So let's talk about how we create subcooling. First of all, definition of subcooling is what? Any cooling below saturation, right? That is my subcooling. So we've always done subcooling. Any Walmart people here? Where we're always taking that lunch circuit off the medium temp and cooling the low temp down to 50 through a heat exchanger. We've got inline, if you've got Husman cases, you've got a liquid line and a suction line braided together throughout to get a little something between the two, the liquid and the suction. We always think about creating subcooling by leaving pressure constant and dropping the what? Temperature below saturation. Are we in agreement?
Yes.
A sound of amen would be good. Amen. So what if I left temperature alone? Somebody give me the pressure at 75.
75?
894?
I mean, you and I know each other.
What if when he's regulating you to 44%, what he's really doing, and I can look in the controller and I can see a reference pressure and an actual pressure, what if I raise the saturation point to 75 and I don't touch the drop plate temperature? Would that be 5 degrees of subcooling?
Yeah.
If I walked in and I took the pressure and I read 894 and then I put a thermal cup on the drop plate and it was 70, how many degrees of subcooling? 5 degrees. Holding it back-ish, yes?
Yeah.
Keep it in the condenser a wee bit. I was just in the Emerson one, and they said the same thing, kind of keeping it in there, letting it go through another pass or so, yes?
Yep.
So that's how I'm creating. What are you doing? He's helping my COP, but he's helping me create 5 degrees of subcooling, right? So that's what his job is in mode 1. Now, you probably asked me what the high pressure control valve is doing. Made this hard to do. So there's, so I just entered here at 894, yes? My evaporator's only good for 650. I don't care if you're using Hussman, Kaiser, Eurozone, us, hell, doesn't matter. They're rated about 650, 45 bar. You see a problem with my math right now? 794 versus 650. So I gotta manage that, yes or no? How am I gonna manage that? So I got a bypass. I got a transducer right there. I simply say, dude, I need to be at 515, 35.5 bar. That's where I want you to be. That's where Hillphoenix, some of the guys, I see some manufacturers are setting at 36 bar. Some are setting it as high as 38 bar. Okay, whatever. Ours is 35.5 bar. Just know what you have to control. But then I simply tell him to manage the vessel, yes? And he simply opens and closes based on that pressure and the load coming into it. How much load do I have coming through here? How high of pressure is it? How far is he open, yes? Mode 1, he's probably, depends on where mode 1 I'm at, 30, 40, 50% open. Are we good? Wherever it's necessary to get to. Those of you who are using a 326A, go to little U24, and that's where your set point will be, or where your pressure is. Or excuse me, how far open the valve is. All right, so then I'm not going to do the rest of the system. Let other people do that. We're just here for one thing. But remember, I'm running 35.5 bar or 35 degrees. Yes? My expansion valve's happy with 35-degree liquid? Yeah, they are. So I'll let everybody else tell you how the controls are working. So I'm managing that to 35 degrees or 35.5 bar, 515 PSI. Wait a minute. Can you guys help me out for a second? So I'm gonna pass the CCM valve around. Now, Emerson just came out with their Alco version of this. It's still a 4-wire stepper. My man Ryan was bringing up a great point earlier. Have you ever heard of a valve that will maintain a pressure to give you a temperature? Anything? Say that again out loud. Is this EPR-ish or not? All he's doing is manage pressure, i.e. temperature, inside the receiver. He's opening and closing based on giving me the right pressure and temperature inside the vessel. So I don't have to make him hard. I don't have to make it hard to understand. Matter of fact, if I Google CCM valve, I will see it says EEPR. Are we good? Don't make it harder than it has to be. If I have to replace it, I simply take the top off. Are we good? Anybody ever heard of any kind of controller or a tool that you may have available that can open a 4-wire stepper? Anybody? Anybody? Man, you guys are so quick. How quick you got that. Will this work or not?
Nope.
How many of you have done it?
Oh, yeah.
I've run a rack with this thing. Only thing I'm going to say is switch the red and green wire. So when you open, and you close, you close. Yes, sir.
I mean, even if the SMA works, where I've had it where the SMA is stronger than the EKC, and the EKC will fail.
And the EKC will fail?
Yeah.
So I'm taking that off the EKC. I'm taking the wire straight off of
Straight
there
off.
and going straight into the CCM valve.
Yeah.
So I'm not part of that.
No, I'm just saying, even if you test it with that, it's not no guarantee.
No, it's not, but it's a tool that I can help. I can always kill the power if I think it's not zeroed and let it zero. There's other things, but and there's a Danfoss version of this as well. I think there's like $700. What is it?
385.
385 Danfoss one? But this is the only kind of thing I can do to help drive a CCM. The thing is, the steps are different as well. So my man brought this up, great point. And I didn't know if I was gonna do this or not, but since it was brought up, if I have to test one of those valves, how many of you can test the DC signal coming off here to see if that thing's actually driving? So if I take my meter, I switch, I wish we had a rack running and we could do this. But if I take this to DC, and I simply take this, it's a 4-wire stepper, yes? Means it has 2 sets of stators as it drives, not a unipolar with 6-wire. So if I simply take my meter, I go, somebody stole these for me already. If I simply take this and I put it on the white and black wire, on one set of the stator, I can see my meter go positive, negative, as it moves. And like if I'm using Danfoss, I can go to little U24 and I can simply watch and see how fast it's moving, and I will see this moving at the same rate, right? And then I switch and it'll go positive, driving one direction, negative. So it might be like the one I was at last week. We were running around 4.6 volts positive, 4.6 volts negative, 4.6 volts positive, and we were moving very slow because we were right at set point. So we had to know that. Then we simply went over to the red and green wire, checked the valve, and we can see the same thing, positive and negative. I've come up to some and just seen it go 30-something on one end and like 2 on the other. And we tried to force it to run by simply closing the flash tank off, and it doesn't move. We change the valve. Are we good? But the SMA 12 is my first offense when I try to drive that. There's anything else? Where were we at? All right, so we're managing the pressure here. So is everybody good? This is a reduced version of what I'm usually teaching, but we're good, yes?
Yep.
Everybody's good? So I want to get my volunteers up here. Anybody see my clicker?
You have it.
I'm so damn ADD, I can't keep track of it.
Is it the SMA maybe?
Ah, it's on the floor, of course.
Oh, there we go.
Of course it is. All right, so that's mode 1. Is everybody kind of cool with that? We're not going to talk about the rest of the system. We're just going to say, what do you got to get good at if you're doing CO2? Those of you who are new to CO2, here's what you got to get good at. Typically, when I think of 515 pounds, I think what? If I've not used CO2 before, I think 515 pounds, I'm thinking what? High head. Even 410, that's high pressure. That's high temperature. But with CO2, 515 pounds, 35 degrees. 35, we gotta get good at that. All right, so now let's switch over to mode 2. Everybody ready to go to mode 2? Everybody wants to talk about mode 2. Mode 2 is because I'm now going what? Say it louder. I want to go transcritical. I want to see this. So, quick definition of transcritical. Transcritical is a transition from subcritical to supercritical. And then you're going through your gas cooler and then back. You're transitioning from subcritical, which means you're below the critical point, to transcritical or supercritical, which means you're above. Everybody good with that? When they talk about that, running transcritically, just understand it's supercritical. Supercritical means the density of the liquid and vapor have reached the end of the density scale, and now instead of 2 phases going up, I have, like in the condenser, instead of 2 phases, I have a single phase that I cannot condense because it's non-condensed, it's supercritical. I just have to figure out a way to drop the pressure. I gotta drop the pressure. So I'm gonna go over here. I'm gonna come right here. We good? Let's go to this one. All right, so what's going on? First of all, intuitively, I'm running at 94 degrees. It's running about 1,200 pounds. How far open is the high pressure control valve? Intuitively, what would you say?
75.
Wide ass open. Yes or no?
Yes.
Any regulating valve that's wide open is now a ball valve. Yes? This is not a ball valve. Regulating. People, 100%, 50, 80. No, dudes, it's going to be running up and around the mid-50s. I've seen it run as low as 40, 42, 45-ish. Doesn't stay there long. So what is it doing? What is he doing? Why is he regulating? Where's he going? What's he doing? Here's what he's doing. Because I believe if I tell you how it works, you can fix it when it's broken. So what happens is, I'm now running, I came here, I was subcritical, came off the discharge of the medium temp, discharged up here because the ambient's high. Well, let's do it here, I got bored, forgot. So I'm coming here, I'm going through the condenser, or I'm right here at the compressor, right? Are we good? Are you with me? Above here, 99 degrees, that's here. What's another one I had?
Saw it sitting on them.
We go at 104 like we did that one day. All right, so we're coming out here. It's no longer a condenser, it's now a gas cooler. My fans are wide ass open. I'm just trying to get as much heat as I possibly can, yes? Yes. Almost like de-superheating. But I'm just blowing it. I'm just trying to cool it down. So what I try to do, so this comes experimentally. You saw how many people were in Emerson's right before lunch. They use the exact same numbers on their controller that I'm going to use. And what we're saying is 100 bar, 1450, 100 bar temperature, 104 Fahrenheit. They're going to pick an isotherm. You see my isotherm, my temperature lines, and it's going to say, okay, 100 bar temperature, boom, I'm creating this line here, yes? I create a reference point. Everybody with me?
Yes.
Where? Experimentally from the Danish Institute of Technology. This is where this comes from. And so what we're going to do, when I'm transcritical, am I as efficient as I am when I'm subcritical? No. I'm losing efficiencies, yes or no?
Yes.
It's a fact. That's why we're doing parallel compression. That's why we're looking at ejectors, how to make this. But remember, we have 7 of these in Miami. We got one in Louisiana. We're putting them in Houston. We got 4 Trader Joe's in Arizona. So they work in higher ambience, but just not as efficient. Are we good? So what I'm doing, I'm trying to manage COP as best I can, right? I want the best efficiency through the compressors that I possibly can get. So I'm going to call this my COP curve. Yes, you see where I marked it here? COP curve. So what I'm doing is, as the ambient pressure change, would you say I'm running up and down the COP curve? I'm here, I'm here, I'm here, depends on how far open he is. And what he's doing is the ambient temperature coming out of the condenser and all that change, he's moving me up the COP line. Is everybody good? Yes or no?
Yes.
Yes.
I hear yes, but I see, I'm not sure. COP, coefficient of performance. I'm trying to make this the best I can do. So when he comes, why is he at 45? Why are you at 50%? He's moving me to this point. Now I've got the best COP I can. I'm right there. I'm right at the entrance. I'm right. Look at that valve. Oh. You tricked me. So it's right here at the beginning of this valve, yes?
Yep.
Sitting right here. What's going to happen when I push through this valve, through the orifice, through the opening of this valve that continues to change? What's going to happen to my pressure? Say it again. So, let me ask you this question. You guys are great men at refrigeration. Have you ever heard of a valve that would take refrigerant in one state, and then as you push through that valve, you create not only a pressure drop, but you create a change of state? Anybody? You can say EEV, but I'll go TXV, yes? I'll go a plug dryer. I can't, I'm going school, baby. Yes or no? Is this acting as an expansion valve?
Yes.
Don't make it harder than it has to be. So he's changing state. Once he gets here and he pushes through there, what's he doing? Changing by dropping the, to what point? 515. Yes? I always like to ask this question. Does an expansion valve know where he's dropping the pressure to? No, he doesn't know. People go, well, the compressor is setting the, no! The compressor's setting the pressure, yes or no?
Yes.
I'm just changing state and dropping down the suction pressure. Amen? Is that what he's doing? Transcritical is not that hard. We good? We just have to think about it in those terms. Don't do CO2. If you start to panic, here's what I always say. If you're in Iraq and you start to panic, here's what I do. I step back, step outside for a minute, and go, don't worry about it. Channel your inner Bob Marley, you'll be perfect. Yeah, man, it's good, brother. And you just go in and do what you have to do, amen? Amen. That's what we do. All right, so now he drops the pressure. One of the reasons, you ever wonder why, some of the reasons we picked these 2 points, if you ever drop this in half, how many of you remember the lines of volume? I knew you would, Trey. I was actually going to call you out on that. But that means from here, I have lines that can tell me how much percent liquid to vapor I have, yes?
Yes.
And I want to be on this side of the line, yes? Because I want more liquid than I do vapor. And that's why one of our set points, in our controllers, one of our set points, and I'm not going to tell you N99 on the damn faucet because I don't want you to change it. And if I tell you, you'll change it. But that helps me pick that point, correct? Because I can move it, and it changes the slope of the COP. If I change that, now I'm going to kick prematurely on high head. All right, so don't change that. Is everybody kind of cool with this-ish?
Yes, sir.
Now, let me ask you this question. All right, so we've changed state. My man here is how far open is he? My flash gas bypass valve. Dude, he's jamming. Yes? Where do we lose the efficiency? Because at points, I'm running 30 to 40% of my refrigerant straight back to the compressor, yes? That's why we're doing parallel compression. That's why we're doing ejectors. To get that percentage, take some of that mass flow off the compressors, change it to a higher saturated suction from the plus 20 to plus 38. So I can reduce the energy, yes? Yes. So that's what we'll work. It works supercritical. It works in Miami, where it goes 87 around January 5th, and it goes below 87 around December 27th, right? So it works there, it'll work anywhere. Are we good?
Yeah.
Woo! Y'all having as much fun as I am? I feel like a Baptist preacher, man. I'm sweating my butt off. All right, remember where we put our sensor. It needs to be not only for fan control, but for the COP control. I need to make sure that drop light temperature is about 6 to 8 degrees, really 5 to 6 degrees off the gas cooler outlet at 5 or 7 o'clock. 5 or 7 o'clock. Right? It can't be on the top, it can't be on the bottom. All right. Now we look here, we got these rolling, we're doing our thing. Let me ask you a question. Does the store know if everybody's doing their job? Does the store know I'm supercritical?
No.
No. Because as far as the store knows, as far as the case is concerned, it's what?
It's cold.
35.5 degrees, 35 degrees, 35.5 bar, yes?
Yeah.
Store doesn't know. So quit calling me. Well, you know, it's hot out, the case aren't working right. Bro, it's not because of the ambient, it's because something ain't right. You gotta fix it. Amen?
Amen.
All right, so this is kind of how this thing works. Where am I at, time-wise? I'm good. What time have I got? 2 o'clock? Yeah, I'm good. Somebody give me when I have 5 minutes, like 5 to 2, can somebody give me a heads up?
Sure.
So I can wrap it up? All right, so the high pressure control valve, I'm going to go through this kind of quickly because I would rather have you guys come up and play. And anybody who wants to come up and see what we're doing, because we couldn't figure out the damn GoPro. Oh, wait, before I go much further. How many modes did I say we had?
3.
How many did I discuss?
2.
And y'all didn't call me out? What about mode 3, dude?
We're never that cold in Phoenix, so we don't have.
So what we doing in mode 3? We're not doing it in Texas or Georgia very often. You do it in California because in SoCal it snows like hell. Yeah. It's simply a what? Say.
The whole back out.
He's an A8, is he not?
Yep.
He's going down 30%, 20%. What are you doing? I'm simply maintaining about 700, 750 pounds at the condenser. Gas cooler or condenser?
Yes, sir.
Because it's only a gas cooler when the ambient's what? Mark Rudd called me one time. He called me in January. And he says, dude, I have a problem with the gas cooler. I said, you do? I said, yeah. I said, aren't you in Chicago? He said, yeah, I am. I said, bro, I gotta hang up. He said, why you gotta hang up? Well, if you got a gas cooler in Chicago in January, I gotta get to church. There's some things I gotta talk about. Because it's not a gas cooler, say, it's a condenser. As long as it's below 87.7, it's, don't make it harder than it has to be. It's a gas, it's a condenser. All right, so it's a whole back valve. What is he when it's when it's zero out? This is a flash gas bypass. What is he?
Bypass.
He's a bypass valve. Could I relate him to maybe an A9-ish?
Yeah.
He's trying to regulate pressure in the receiver, yes, like an A9 would, right? He's acting like an A8. He's acting as an A9. At least I have a point of reference when I'm working on him. I know what those valves do. He's not a headmaster because I can't cut the process. sorry, I've never heard of that. I don't know what I'm talking about. Living in Georgia, I would never do that. So they didn't send me back to C-stores. All right, are we good? All right, so everybody's good so far. Man, it's cool up here. It's nicer up here than it is down there. I like this. All right, I'm just going to show a couple of pictures. Here's my high pressure control valve, my dam floss, could be whatever, whoever's valve it is, controller. There is absolutely zero excuse. That's just a shame. Yes? Yeah. And if I show pictures and talk about your store, fix them. Insulate that. Sweats like hell. Insulate it so I don't rust. Just shows you some more. These are real quick pictures. So those who have never seen this operate, Permagone, dam floss, microthermo. Where's it running? This is in Vermont. A couple of weeks away from each other. I'm in Vermont. How far open am I? 44%. Now I'm going to be in South Georgia. How far open is he? If we're out here today, I would say we're going to be somewhere in the low 40% open right now, based on our ambient. Maybe even down to 38. Here's why you got to get good at that. How many of you can walk into a rack and hear a certain sound or whatever in the compressor and go, I don't know what's wrong, but that ain't right. Well, man, what are my man back here? They're all pointing to it. Sensei back here, laying hands on. But how many of us can do that? I need you to do that with the high pressure control valve. If you're going to be good at this, you got to be able to walk in with that high pressure control valve and say, what? I don't know what wrong. But that ain't right. That ain't right. Can I get an amen? That's where you have to get good. So we're going to do this. We're going to play with it real quick. I'm going to go do some alarms. Is that a no-go? See it sweating? Look at the gap. Look at the gap. When I put this on here, I got to make sure I clean that gap up. When I pass these around, I want you to look at it. So I just set it on here, right? Everybody see me put it on? Oh, come on, dude. Oh. It's a nice magnetic gear. So I put them on here, but I didn't put them on tight enough. Can you see that gap? So a lot of times, like if I'm field calibrating or if I'm doing different things, I'm doing different kind of things. What I always recommend, I think Paul does too, go downstairs, get your small thing of Vaseline, yes? Don't use POE. It's a solvent, right? Simply take a thin line. You can feel how dry this is. If I simply take a little bit of Vaseline and I put it around here, when I put this back on, what's he going to do? And then put a little bit of pressure on him, what's he going to do? is gonna set, so then when I put my set screws in, instead of putting it on the over-end, I'm following into this gap, I'm pushing it in, I'm getting better surface area and better operation. I had a dude call me, dude calls and he says, tell me what's going on at 0%, the rack is running. I'm like, bro, you need to field calibrate the high pressure control valve. Hey, probably a Husband guy, if I had to think about it. And he says, dude, you can't come into my class with 3 Husband hats in a row, not thinking I'm gonna say something. So my man calls me and he says, I tell him what I think's wrong, right? And I didn't say, dude, you called me. I wanted to. But he goes, you Hillphoenix people don't know what the hell you're doing. Again, Kevlar underwear. I said, not why. You're the 3rd person to tell me, and I think Paul had talked to him before I did, to tell me to field calibrate it. You guys don't know what the hell you're doing. I said, bro, before you get pissed, let's do this. Why don't you do what I asked you, but this time let's do it right. Okay, nobody got pissed at that? How many of you would have hung up on me? That was my goal. He goes, what do you mean right? I said, don't just set it on there. Put a little lubricant on it, push down and rotate counterclockwise. Counterclockwise is the closed position. Rotate it counterclockwise, you'll feel it slide in. Matter of fact, if when my volunteers come up, I'll have them do that and they can tell the difference. Right? So calibrate it right. We'll put it in there, I'm gonna do things, but make sure you use some kind of lubricant on here and get it on. Is everybody good?
You spit on it?
So those are some of the things I'm on my way. Stop it. I know how you guys are. Stop it. As soon as you ever say something you want to catch it, and it's too late. Put all 3 set screws in. It ain't a heat craft condenser where I'm putting like 2 back in. I need 3 set screws. I need all 3 of them in. Appreciate you getting that, Leslie. I want to put them in. I need it to be tight. I don't. Where's Matthew? We were at that one. It looked like the damn Leaning Tower of Pisa. I'm like, what the hell is that? They had 1 screw in. I'm like, dude. I didn't mean to call you out. It wasn't Matthew's fault. It was one of the contractor before him.
Yeah.
So what happens if I lose one of them screws and it's 2 o'clock in the morning?
Oh, shit.
Good question.
What are my alternatives?
Well, what I might do, you can always take the one out of the oil sensor
One of the
because
oil
they're the exact same one. Not perfect, but it'll work in the middle of the night. Remember, we told you we were going to do some down and dirty things, but I'd rather have that high pressure control valve working. If it's still going to work, take it off the reservoir. Are we good? Yes? All right, so those are some things. Make sure that's tightened up. Insulate that. Can't believe people don't insulate that. All right, when I look at it, you recognize this? That's the Duluth. When I pulled that one up, I'll show you the magnet on this one in a minute. Does that look good?
No.
I don't know what's wrong, but I know what's wrong. They didn't do it right. All right, I'll show you that. So here's my actuator. Hey, do me a favor. Can you rotate that for me? Mr. Strong Guy. Now I'll rotate this one.
Oh, man.
Because I got power to it. It's not an electromagnet. I'm not burning the coil up, but you can tell the difference between rotating it when I'm doing that because it's holding it in place. Because I got a 0-volt signal, so he's going to 100. We'll get to that later. But I do have them. I just wanted you to feel the difference. And I'm going to pass all these around. All right, and there's the magnet. What's the magnet for? Most of you know what the magnet's for. What's it for?
Manual control.
It's a manual tool. If the actuator fails, what would I use?
Magnet.
How many people know where your magnets are?
Should be. Not all of them.
Those ought to be locked up tight. I would take this, Publix puts them on a chain.
That's a good idea.
So you can only go to that thing and you can't, I'm sure we got 10 steps so we can cut it, but at least I'm gonna make you work for it. But I'm gonna pass this around, I want you to rotate it. Look how I can see him go up and down. Everybody understand why I'm using him, right? The actuator is fragged. I have no thing, it's not working. It's stuck. I gotta get out of there. Take your magnet, look at your pressure, drive it open or close, yes?
Yes.
So I can use it. Every shop, damn, that was violent, wasn't it? Every shop has a first dealer, yes? Everybody knows what the first dealer is, right? Well, I'm gonna be on a call next week, and I may get a call, so I'm gonna take the magnet before, I know Mike's gonna take it, so I'm gonna take it first, so I'll have it in my van, right? We all have a first dealer. I knew you was gonna do that, I was watching. So let's say the first dealer got to me, and he's dead. Pressure's running crazy. And I'm trying to figure out a way to drive that valve.
You could use that, just undo the screws and use the same head and turn it.
Can I use this?
Yeah.
See, you know why he's so smart? He's got a great name. Can I not loosen these up and simply use this as a tool to get me out of there?
Yep.
I most definitely can. And so that's another trick that can help me get out of there in the middle of the night and run and not lose product. I can drive that, Mr. Matthew.
Would there be a reason why you couldn't use that? Is it locked up or something?
I'm just saying, let's say I'm not reading on the digitals or whatever reason he's giving me an alarm on the A2 and I can't reset it, then I would use that because I just can't use the actuator.
I didn't have a magnet on one recently, and I tried to use the
Actuator?
controller.
Was it good? Was the actuator actually good?
That I don't know.
So we're going to try some things. Matthew's bringing up a good point. I'm only using the magnet when what's bad. Let's say he's good. I'm going to have my volunteer, I think. Let me check where I'm at presentation-wise. There it just shows. This one was actually running 2 weeks on the magnet. Don't do this. So I went to this store that's in Hillphoenix, Duluth. They said the high pressure control valve was bad. Really? So I took it off and I looked at it. Y'all know what white thermal paste is?
Yes.
Should white thermal paste be on a magnetic gear?
Totally, yes.
Stop doing it. Well, man, they tore this actuator up so bad with this thermal paste, you can see the magnet here, that there was actually shavings from the valve itself inside of there when I first took it off. They said, give that back to us. I said, no, you don't deserve it. Matter of fact, go sit in the truck and wait till Daddy's done working. Some people, you just gotta take your tools away, right? That's a bad thing, yes or no? I still have this in my house, I would not give it back to her. No, I'm gonna put this in the museum. All right, so, who's my volunteers? Volunteers, come on up. So, the first thing I have is a red valve, or red leg. My red is power. Gentlemen, am I powered up?
No.
On this first one.
You are.
Show them and tell them what you got. 2. What do I have?
A1, 0.
A1. Is it flashing?
Yeah.
Give me all the description, baby. You're the teacher.
Flashing, A1, flashing 0.
What does A1 mean? A1 simply means, oh, let's do this. Oh, let's not go there. Let's go here. A1 simply means what?
No valve type selected.
I haven't programmed it. Let me tell you a quick story about down in Louisiana. My boys called me from Louisiana. Those of you who know the 326A know that if the vessel pressure goes down too low, the high pressure control valve will open up to 100% to try to compensate for low pressure in the vessel. So here's my boys. You guys help me. I'm going to have these guys help me. They called me and said, hey, they're getting an A1 alarm. What's wrong, Matthew? They got an A1 alarm. What is that?
Not programmed.
We're not programmed. So what do?
Programming.
We go through the programming. Not many steps, so we program it. He says to me, now y'all are me and I'm him. He says, well, it's doing the same thing it was before we changed it. What do we know now?
And it was probably good.
It was probably good. I said, what was it doing? Is that what you would ask?
Yes.
Yeah.
What was it doing?
What was it doing before?
It was at 100% all the time. We couldn't get it down. What's your next question?
Is there program.
Program and B, that's where we always want to go, but let's go old school a little bit. Remember I said there's a 0 10 volt signal coming from the controller to tell them how far to go? If it's 0 to 10 and that's 0 to 100, it's a nice linear number, yes? So I asked him, what is the voltage coming to the high pressure control valve? He said, 10 volts.
100%.
Help me.
100%.
How far open should the high pressure control valve be? 100%. Do you see how that's a valuable troubleshooting tool? Understand what the question is, yes or no?
Yeah.
He was asking himself the wrong question, yes? He was asking me, why is the high pressure control valve at 100%? That's not the question, is it? The question is what? Why is he being told?
Yeah, 100%.
Two different solutions, yes? So I just gave you a solution. I said, so the 326A, he had one, it reads in bar, yes?
Yeah.
Matthew?
Yeah.
Reads in bar?
Reads a bar.
So I said to my man, I figured the receiver pressure's low, remember? It'll go to 100%, receiver pressure's low?
Yeah.
So I said, dude, tell me what the pressure is in the vessel. And my man just said, here's what he said, tell me what's going on. What's wrong with his answer? My man said it's 600 pounds.
That's too high.
You're not listening to me. He said the pressure was 600 pounds. Pounds is PSI, by the way.
But it needs to be in bar.
Where was he taking the reading?
On the gauge.
Was he taking it from the 326A?
No, he was reading on E2.
It was reading on E2. Does E2 control this?
No,
Who does?
the 326.
Whatever valve I'm using, 326, iPro, Danfoss, a microthermal, 772, he was giving me the reading from what? The wrong controller. I said, dude, hit the bottom button. What is the receiver pressure that the 326A says? He says -1. What's the problem? He has a bad what? He has a bad transducer. I said, dude, they've been down 2 weeks, Trader Joe's. 2 weeks, say it with me. 2 weeks.
2 weeks.
No refrigerated product. How happy are they at Trader Joe's?
They're going potlucks outside, picking all the meat.
No meat, they don't even have product in the store now. Does everybody understand what happened? You gotta know what your inputs are. You gotta know what your outputs are. You gotta know what controller controls it. Read the pressure the controller is thinking. Don't read some gauge when I know I'm being controlled. Amen? So those are things we learn when we do this. So now what I want them to do, what do I want Mr. Eddie? So this is Top Gun right here, baby, because they volunteered. So I would simply go, I can't do anything to him until I do what? Program. So look, let's say, so now what I want you to do, let's look at some of the alarms. If I get an A15, my voltage is less than 18. That's power. If I get an A8, it's power. The red leg, supposed to be 24. If I get, oh, did you see any other light you like? How about an A8? Thermal overload. The stepper's too high. Here's what I see on a regular basis. Where's it at? A3. Look at A3. Because we're using the IO3, the voltage is 12 volts. The signal voltage is 12 volts. I'm just overfeeding it. 10 is supposed to be max. I'm getting 12. I get an A3 alarm. This is in the manual. This is in the presentation you just downloaded. And it's in the ICMT manual. Doesn't matter if I'm using a CCMT, I look at the CCMT manual. Now, what I want my mind to do, I want Eddie and Matthew, you see my signal, you see the black signal? First, put power to here and tell them how far it goes. Just switch that cable over to the black, or the red, not the black. And tell the class, you're the teachers.
What it says.
What does he do? Can you feel him moving? Look at the bottom, show him the bottom as you hook it up. No, as you hook it up. Don't worry, we're just all watching you. Bated breath.
Point it down.
It only goes in one notch.
There you go.
Turn and run.
What's it doing?
Resetting.
Where's he going?
Zero. Close it.
Why is he going to zero?
Gotta find its home.
What's that?
Gotta find its home.
He's finding his home, and where's the signal wire at?
It's not on it.
It's not on it, so as far as he's concerned, how many volts does he have?
Zero.
Zero.
And it says
So
zero.
now, $27 right now online on Amazon. I should be an Amazon salesman. So what my men are gonna do, this is a signal generator. It'll do 0 to 10 or 4 to 20 if you're doing glycol. So he's gonna turn it on. We're on voltage, as far as I can tell. Yeah, we're on voltage. So I want him to wire, where's my signal? He's gonna wire my signal. I have an orange and green wire, and these Eddie and Matthew are gonna wire it. And then you're gonna go to these two pins. Let's see, where am I gonna go? So you know, go to these last two. You got a ground and a positive.
Don't you call that the Jesus valve?
People call it the magic valve. In Canada, they all call it the magic valve. I almost threw rocks at them last week.
Wow.
That's all they did. Magic valve, magic valve. It's not magic. I took the magic out for you.
Hey Rusty, these are all alarms related to the valve regardless of what controller you're using, right?
Doesn't matter, and that's what we're focusing on. So I can get an A7 and it doesn't matter if I'm doing an iPro or whatever, and I'm sending too much voltage, I'm gonna get an A3. If it's not programmed, I'm getting an A1. Great question. And so this is a great thing to have in your truck on your tablet or your phone if you're using these high pressure controller. All right, so where we at? So we should be at 48%.
Negative. So then go.
Wait a minute. Okay. Hold on, technical difficulties. My man said he's got 4.8 volts. Let's go 53% open. 5.3 volts means 53% open, and we are.
Zero.
Why did I pick you guys? So, maybe I have a broken wire. Maybe I set these dudes up. They wouldn't be past me. So Matthew actually turned me on to these. So hook these up to my meter. You remember what positions they were? I'll help you. So I'm going to look over here. I'm not going to do that. It's Rusty Wall. That's the last thing you guys want to see. So, my men are going to go. It's pin, if you look here on the cable, black cable, so, of course they're not looking. If you see your indentation, put that at 1. Then I want to put my meter on F and D. Those are going to be my signal. So he's got the pointing meters. He's going to hold this at 1 o'clock. You see the indentation? Where is it at? One of you got to hold the cable. No, you can put that down for right now. So help this one. You guys, one of you do the meter, one of you hold that. Put it and read F and G.
F and G. F and G.
F and G.
Okay, so let's go G and F. Oh, it's not even G, it's E and F. So you want to go, you see them? Go D and F, 6 and 9 o'clock. My meter says, Ryan, what does it say? Is he on DC?
Yeah.
And he's on 9 o'clock and 6 o'clock.
Go to DNS?
So you go F here, D is here. So you only got 1, go to 6. The bottom. And you have, see if you can get a better connection. You should have 5.3 volts. Is he on the right one, Matthew?
I'm blinded.
So sometimes you have to get in there really good.
Rusty.
Did somebody say Rusty, or is it the voice in my head?
Complimenting your song.
Because I tell you this, there's so many voices inside here, I never know if it's y'all talking to me or those guys. We got it? Because what's cool about this is, have you ever been to Iraq? You guys been to Iraq yet? You ever see the miles and miles of wires that we have? They go from here to a terminal block, and then off the terminal block, and then through the compressors, and can I check a broken wire this way? Read what's on the controller, whatever it is, and to read DNF.
There you go. 5.3.
Wait a minute. You have 5.3 there?
Yeah.
Hook it back up. You should have 5.3 there, yes? Hook it back up.
Unless the valve's back.
You think I set them up for failure? Yes, I did. What are you reading?
0.
All right, Matthew, do me a favor. Eddie, you help Matthew here real quick. Look at my drawing and my labeling and my wires, and then look at the way you wired it.
Orange is ground and green is signal.
Just because it's green. So what did they do? Is green ground?
No.
Orange is ground. But what did they do? Where did they wire the green one to?
Ground.
Ground.
I'll stamp off.
So they were getting the signal, they were backwards, but they just switched their meter. But now, once they switch the thing, what's gonna happen? I'm gonna get by, hopefully, or this whole experiment, I'm gonna look like a dumbass.
New noise.
Where we at, Matthew? Eddie, what we got?
52. Oh, we're not.
Everybody good with what we just did? Alright, so, I want you guys to stay up there, because I like the view from up here.
And the AC.
Matthew, the actuator is good. The iPro, or whatever controller I have is shot. I can't find the magnet, but the actuator is good. Are you going to take and use the actuator to turn it because you don't have a magnet?
No.
Here's what I want you to do. One of you two, or both of you guys, I want you to hold the center button down till you get to IO1.
IO1.
Now I hit enter again, the center button. What does it say?
52.
Says 1 or 2?
Oh, 1.
Change the 1 to a 2? Binary, funny how that works. What's it doing now?
You press enter or what?
Yeah, when you hit enter,
Now it says IO1.
IO1. So now what's gonna happen, did you feel the valve move when you did that? Sorry, my bad. Tell me when it times out.
I didn't feel it move.
Time out yet?
No.
Yeah, because we're waiting on it. If we weren't waiting on it, it'd time out too quick.
There it goes. It timed out.
Now what does it say?
46.
And it's doing what?
Blinking.
Flashing. Change it, I wanna see it at 42%.
Press enter.
No, you don't have to. Is it flashing?
Yes.
So what did we just do, gentlemen? We simply took it to manual, we knew it, because we pay attention when we go in there. We know it's supposed to run about 42%, so I simply did what? Put it in manual. How do I know it's in manual? Matthew, how do I know? It's flashing.
Oh, okay.
If I ever walk up to a rack and it's flashing, I know what?
Manual mode.
Somebody's put it in manual. Alright, so that's the thing that gets me out of there. If the actuator's cool and good, I can do that instead of using it. It's more accurate than the magnet. Yes? How many people have used the magnet before? It's kind of like, I think, right?
Yeah.
Alright, now what I want you to do, let's do a software calibration. This is something I can do, kind of zero the valve out, and I can do it while it's running. I refused to do this for the longest of time until Yoda told me I'd better do it. Once I did it, I do it all the time. And by Yoda, I mean Mr. Burnett. So, what I want you to do, I want you to hold the center button down. What does the center button give me? You can do this in manual, I believe.
IO1.
You might want to put
I
it on
want
the
to
valve.
L5.
You might want to put it on the valve.
You can, but it'll work without.
will, but it'll just keep running to one side, unless you try to hold it.
I was gonna show them how to run without, but go ahead. It's not a coil, it's not a solenoid. Right, go to
It
IO5,
says 0.
change the 0 to a 1. Enter, feel the action at the same time. What do you feel it?
Yeah.
You see how he's calibrating himself out and zeroing himself. I'm actually coming to the point, like Paul said, is this is not a bad thing to do at maintenance. This does not hurt this valve to do that. But you see how hard it is to pull it out now?
You can do that while it's operating, and if you're at startup, you can change that 1 to a 2, and it does a triple calibration.
I've never done
So,
two.
does everybody see what we did?
When you go to
These
the
are just
triple
different
calibration,
tools we
you don't
can
want to do
use
that when it's running.
to get out of there.
You don't want to do the triple.
You want to do number
But
1.
you can do the 1.
Yep, every time you're up there,
So you
do
go
maintenance.
5 and then 1.
Yeah, and I think we did that, didn't we do that when I was out there at your school,
Right.
or not?
You only have number two, right?
All right,
Yeah, you only have number 2.
So-
One's the bottom, right?
Yep, 1 and 2.
1 and 2.
1 is a short and
So
setback
why don't
point.
you want to do it during startup on the besides startup?
During startup, do it 2,
But why don't you want to do it during?
because that's a longer calibration and you're gonna change.
So we'll go to
You're
0
gonna not
and-
have control of your condenser.
So
Yeah.
we'll go to 0 and then open back up and then try to reset.
You
it?
know what it
So
does?
close,
It won't
close,
It,
shut
close.
the
it
valve.
goes
Yeah.
stop, stop, then goes back to signal
Oh, okay.
on
I see
1.
what you're saying now.
On 2, it goes stop, 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 stop,
So the
signal.
condenser, you're just stacking, tripping on ahead.
Yeah, it's just quicker, and it's, once you've got it running, everything, it just resets everything.
Does anybody know what the maximum operating pressure of the vessel is? It's set up in that controller.
Depends on the controller, but you can change it.
This one is 40 bar. 580, right?
I mean,
So what does that mean? If you lose the rack shut down middle of summer and that vessel pressure rises to 600,
You're gonna pop off.
not yet.
cause
That-
it's 650.
But that controller is now going to go into safety mode. It's going to say, I can't control my vessel pressure, so it's going to shut the high pressure down. High pressure valve is going to go, rack's going to pop off on your discharge. Excuse me. Now to start that rack back up, what do you got to do? You've got to get that vessel pressure below 40 bar, 580, right?
It's gonna be a bar.
So I always tell everybody, bleed it down to 550, turn the rack back on, it'll start itself up. Because if it doesn't, it's gonna, that above 40 bar, that
All lights
the
are gonna blink.
326A is gonna keep that controller at 0.
And remember, you have to understand what your set point is cause they're not always gonna be 326As, cause the 326As are going to sundown mode.
Have you seen S20 alarm?
Oh yeah,
Yeah,
it looks like 520.
Yeah,
The
they're
first
like
time I saw it,
520.
I looked for 520 for 5 minutes.
I've had
And I'm
those
going, I wonder if that's the next.
downfall sensor, like the drop leg, right?
yeah, that's on the 326A.
Yeah, that's your drop leg temp sensor. Now, maybe it's loose. That's why you check it on startup. Can you do that? Maybe somebody disconnected it at startup, put it back in, didn't clear the alarm.
Could be
How do you
bad
clear the alarms
sensors
in the
while you're-
326A?
the
I
drop leg
just ran it
sensor.
straight in, not off the terminal block, and bypassed
Yep.
ran it straight to.
How do you clear the alarms in the 326A?
They clear all
Bottom
the-
right.
326A class, so don't listen to these guys.
Yes. Bottom right, black and white. Pull one of them off. Powers it off, powers it back on.
Here in 10 minutes.
Clears the alarms.
Can't you just pull the PMR relay? Go off?
You can do that, but you're gonna kill the whole rack.
Cause that's gonna open the DI1 on the
Pull one of the,
326A.
pull one of the black or white or
This-
pull them both?
Really, if you just unscrew the black wire, sometimes it'll make enough of an air gap. Shift. See, I get off on a tangent.
See, I knew when I called on him, it was not gonna end well.
You got 10 minutes, Rusty.
Yeah, I know, and I got a lot of stuff, so, yes, real quick.
Can you re-describe how to do the auto calibration portion?
Which one?
E43,
Go to AI5.
What's that?
AI5.
I'd have to look, remember what it is.
like motor.
Isn't that phase out of balance? Yeah, that's, usually when you and I were talking about, where we were out that worm here, for some reason it's been bouncing back and forth off the thing, for some reason. Usually that happens down there, where you have 2 326As.
All right, gentlemen,
They have to be set for different
all right,
controls.
so due to time constraints, we're not gonna watch that. We're not gonna watch that. I wanna give the hand to Eddie and Matthew. I think they did an awesome job. I would hire them if I were looking. Although I don't like the source, why don't you look where it cool sits? Alright, real quick. No, I'm good. Thank you. Appreciate you. Yeah, so Matthew and I blew up a 326A together. We put power in DI1, fragged it. So you know when you blow something up together, it somehow bonds you together.
We triple store.
Because we did this, we both looked at each other and go, huh. I said, hey, you got an extra 326A? He said, I thought you did. Who knew? All right, don't put voltage on the DI. All right, so this is a simple stepper valve. Real quick, because I'm running out of time, but let me tell you this. This valve manages pressure inside the wire. Flash tank. If this dude frags on me, I can do the 326A, I mean the SMA 12 or whatever. But if I don't have an SMA 12 and the pressure goes too high, what would you do? So we've taken this out to save $1.25.
Use your
You
manifold.
don't have that anymore. You're more like this. Oh, no, I'll show you that one in a minute. I'm more like this now. What would you do? Pressure's too high.
Use your manifold.
What?
Your manifold.
You mean you could actually take a refrigeration manifold and hook it up and tie it to the suction of the medium temp
Yeah.
into the access port on the receiver
Yep.
and actually manage it that way?
Whoa.
Who knew? Old school's the best school, yes? My great Panthers represent. Are we good?
Good.
Simply put a gauge on it. Regulate the pressure that way. If it's going too low, what would I close? Anybody got any idea?
Ball valve.
I can start throttling it, or to prove it, I can just close it and see if the pressure jumps up. Or I can actually regulate through there. Or if I happen to have a bypass valve, I can regulate it through the ball there. There's no reason at all for that receiver pressure to be stuck because that valve fails, yes? You can use your gauges, you can use that valve, use the tools you already have and simply drive them. Are we good? Does anybody see a problem with this?
Yeah, the wire.
Big EMS was pretty.
Somebody cut that out.
Now, does anybody see any problem with that?
Yep.
I almost lost. I can't think of a good word I can use. They simply disconnected this bit line, brazed it shut, but when they did, they took out the hot gas dump. So now there's no protection against flooding. Well, get the expansion valves working to make sure the defrost works. But other than that, are we good? Y'all fixing to go fix this one?
Where's that store at?
It's the one we were at in the
Laverne, huh?
place.
It's Laverne.
In the place.
Where the thing is that.
Yeah.
It's Laverne.
There was a what?
Aldi's Laverne.
Yeah, that's what I was thinking.
So no sharpen at all these.
What?
Yeah.
What?
Over in a couple weeks.
Where was it?
Laverne.
Whatever he told you.
Laverne, Tennessee.
No, this was, no. It was down the street from here somewhere. But, yeah, that's where we blew up the 326A, the same store. So just remember, these are all great pictures. You have these pictures. This one is in Eastvale, down on Rancho. There's another picture. They're just simply stepper valves and EPRs. That's it. All right. Gentlemen, I'm trying to do a wrap up.
Can you put the code,
What's that?
can you put the code back up there?
Which one?
The scan code, barcode, or the, PDF
What do you
code.
say?
The first
Barcode. Oh, the barcode. Yeah. Okay. Well, I'm gonna do theirs, then I'll do mine. All right. There's theirs. Gentlemen, here's my takeaway. Nobody's gonna listen to me now.
They're getting specific because now you should be taking it down.
So I'll put mine up in a minute. Who didn't get it? Here's my end of whatever, my point, whatever it is. Don't make this harder than it has to be. There are tools and tricks that you can get to troubleshoot the wire, to read the cable, get a different set of needles. What is the voltage coming into my valve? Who tells me where to go? Is it the E2? Is it the 880? Or is it the iPro? Or the 742V? Understand where your inputs are. Understand what your outputs are. And understand your tricks, your jumpers, if you will. How do I get out of there? How do I regulate pressure? And do it safely. And do it without killing the rack. Yes? Don't do things like it's going to flood the compressors. Don't do things like that. But nothing I did here is going to damage the rack. Yes? And all you have to do is download the ICMT manual. Download the flash gas bypass manual. Go get the new racks. Instead of having the ICMT, it's going to have a CCMT valve. This is my high pressure control valve. But he still operates in those different modes. He's still operating around that COP line. He's still doing the same thing, but he's a 4-wire stepper. He's a 4-wire stepper. Understand what pressures I should see. Understand what I'm looking at. And this thing is super, super simple. If somebody were to pay me to do booster only, I would do that in a heartbeat. Because it's so simple. Don't make it hard. One last story and show you how people get weirded out. I had a dude working in New York City. They call me to go to the store. Dude's freaking and peeking. I get up there, my man's on the phone calling for a refrigerant. I'm like, because he's blowing off on the vessel. Should he have been doing that right at this point? Calling for a refrigerant.
No.
No! Dude, we haven't fixed nothing yet. What are you doing? My man went CO2. You can say it, it's okay. It went CO2, panic, CO2 stupid. So my man he couldn't focus. Sometimes you have to walk out of the motor room when you get into a situation like that, then come back in. Is that good?
Yeah.
In our case, it was simply a breaker on the medium temp, had tripped. Took the whole store down, all the product gone, because he was so focused on suction pressure. Well, he should have been, but he's looking at the vessel pressure. Focus on what's broken. Is everybody good with me? That's a symptom. The high pressure in the vessel was not the problem, was it?
No.
It was a symptom of not having enough capacity to bring the suction down. The best way we fix it is I send him to the bodega to get us some pizza. Sometimes you just have to do that. Look, one last word I'm going to say. If I can fix these things and I'm at the lowest common denominator, then you guys ought to be able to rock with this, yes?
Yeah.
This should be absolutely zero problem for y'all. Are we good?